A quest to discover the star system of TOI 700 and its planets is about to begin for you. Explore the universe beyond our world. Who knows, we might come upon a planet with intelligent life. So grab a seat and come along as we explore the strange world of exoplanets. Our goal today is to determine whether life is able to exist on the planets of TOI 700. Hello and welcome to KYC News. Please don't forget to subscribe and hit the bell icon. The solar system, the 4 planets surrounding it, and the circumstances under may create a habitable planet. What we find could be unmistakable proof of beyond our planet is life. So let's investigate. There are several planets in the universe. Experts speculate that there may be life elsewhere in the universe. Space researchers carefully scan the sky in the hopes of spotting one of these people. One day, they'll be able to locate the planet with inhabitants. It can take a while before, although it's exciting to consider, we find it. Watch closely to investigate the potential for stay with us. The term exoplanet is being used frequently, but what does it actually mean? Planets known as exoplanets are those that are outside of our solar system. Researchers have found a lot since 1990, and some of them are close enough for us to perhaps take a photo of them to see if somebody will be residing there in the future. How are these planets discovered? TESS is a unique mission that NASA is now conducting to identify planets around stars in the universe. 4 planets are in orbit around the newly discovered star TOI 700, which was identified by scientists. Latest research has shown that the star system may have 2 planets the size of Earth that could may be livable, which makes the possibility of finding extraterrestrial life there promising. Outside of the solar system, with regard to the investigation of inhabited worlds outside of our solar system, we need to acknowledge how little we currently know. We are unable to provide an accurate assessment. How frequently life exists throughout the universe and where it is most likely to appear. Because the universe's laws are consistent, the prerequisites for life might be predicted, and we believe that by focusing on what makes it work, we can more precisely define our requirements, making the prototype livable planet's creation simpler. It resembles a young girl sketching out her ideal romantic partner. So, the ideal planet must check off the following items. 1. Rocky planet similar to Earth. 2. Atmosphere is thin. 3. Having a certain size, comparable to the size of the Earth. 4. Possessing liquid water, which denotes that. 5. We are close enough to examine its biomarkers. 6. Rotates a star using a constant and reliable energy production. 7. Using roughly the same quantity of heavy. 8. After enough time has passed for the necessary elapsed to cause the ecosystem of the planet to undergo significant changes. A suitable star is the initial prerequisite for the genesis of life. If a star has a mass of, if the imbalance is too great, the planet's evolution will be quick and any life on its surface will be burnt, without providing for further explanation, after a few 100 million years. Alternatively, if the star is of the smaller red dwarf variety, the planet needs to be in a close orbit to attain enough solar energy, but atmospheres won't be able to withstand the star's flares since they'll be too weak. There must be a point in the middle where long-term habitability is likely. A crucial factor, perhaps even just as important as the first one, is the makeup of the planet we are investigating. Planets with a solid surface are those that we are most interested in. Can step on and have an airy surface similar to Earth so that living things like ourselves can exist there. This implies that planets need to be the ideal size. They cannot be very large or little. It is difficult for living organisms like us to survive in the thick atmospheres of planets that are too massive for survival, but if the planet is too small, it won't be able to retain an atmosphere. A planet should be around twice the size of Earth and only 25 to 30% larger than that. More than 5,000 exoplanet discoveries have been noticed and reported. However, due to their vast sizes and low abundance, few would be favorable for the chance of life. The gas's volatile makeup, that is their environment. Many exoplanets that are similar in size despite being close to their stars and larger than Earth, they are too warm to support life. Exciting planets that are far from us in space have been discovered by scientists. However, these planets are too close to stars that emit powerful radiation on a constant basis. These planets' atmospheres could be destroyed by this energy if it is too potent. This renders them unsuitable for supporting life. Because of this, the system revolving around the star TOI 700 making it a fantastic candidate. Let's discuss some of the star's qualities. An red dwarf, a star belonging to the M category. In simpler terms, that indicates that it should be a modest, awesome star. It is only a tenth the size of our Sun and roughly one-third the size of its luminosity. It nevertheless manages to emit sufficient light and heat for the planets in orbit to be able to support life. While the star's temperature is still up for debate, some according to study, it is approximately 1300 Kelvin. In addition to its size and temperature, it's vital to pay attention to the star's brightness. In terms of brightness, absolute, it is difficult to see TOI 700. Nonetheless, it is only around 20% fainter than surrounding stars. The neighborhood's other stars. This might imply that it could support life on a planet. Analyzing the rotation rate of a star is crucial in determining if it is habitable. The stability of the star will be determined by how quickly it rotates around its axis. The system is, and consequently how habitable the planet's environment is. TOI 700 is a prime choice for nourishment because of its relatively moderate rotation. Moreover, TOI 700 has been there for more than 1.5 billion years, allowing life plenty of time to evolve. In the narrow layers separating the planet's surface from its atmosphere, there is a biosphere. If a biosphere were to develop here, it might be able to substantially affect the atmosphere of the planet. Together, these elements form TOI 700, an outstanding prospect for containing a planet that might be inhabited. The star is a tiny one, and cool, with a modest brightness and a slow rotational speed. With this in mind, let's discuss the planets in the system now. Recently, it was determined that TOI 700 tess detected 3 planets orbiting it initially, but there are now at least 4, possibly 2 of which could be inhabited. The known exoplanets that orbit TOI 700 are as follows: TOI 700b, a super-Earth orbiting its star once with a radius that is 1.43 times that of Earth, each 10.3 days at a distance of 7 cents. TOI 700c, a 2.6 kilometer radius mini-Neptune, times that of Earth, traveling 10 cents from its star in 116.1 day orbit. TOI 700d, a sub-Earth orbiting its star once every 36.2 days and having a radius that is 1.05 times that of Earth, days at 17 cents from Earth. It is the first Earth-like planet that has ever been found. Tess that is additionally in the livable space. TOI 700e, a radius-based mini-Neptune, orbits its star once every 16 days at a distance of 9 cents, which is 0.95 times that of Earth. All 4 planets are in the habitable zone of their star, i.e., they might be capable of sustaining liquid water and life. Researchers are eager to learn more. A closer examination of these worlds will reveal more about their makeup and prospects for habitability. Beyond the area that we described as being both within and outside of the host star's habitable zone, surface liquid may still be possible if the yet undiscovered extended or hopeful habitable zone is found. Water under the proper circumstances with a few small alterations to the planet's atmosphere. 4 planets, or homes, make up the TOI 700 system, which is like to a neighborhood. A pair of planets, we don't need to be concerned because TOI 700b and c are too hot for live things like people or animals. Regarding them, they are most near the star. The temperature on the other 2 planets is ideal for people to live in, as well as potential occupants. That is thrilling. They are more likely to being rocky planets distant enough to avoid being destroyed by TOI 700 star activity. The research we have done so far on the star TOI 700 indicates that the habitable zone of the star is much larger than where TOI 700d is located. This indicates that perhaps there is another rocky planet in the star's habitable zone that we have not discovered, have not yet observed with further test data. The sustainability of life is a hotly contested topic, surrounding a red dwarf star of the M type. Often, these stars cause the planets in their orbit to one side is tidally locked to face the star while the other side faces away. The endeavor to explore this star system has a lot to look forward to. TESS will soon start observing the region of the sky where TOI 700 and its planets are located, collecting information to determine if there are any additional planets that have not yet been discovered. There are designated targets for observations made with the espresso instrument on the ESO's Very Large Telescope. Analyze the TOI 700's movement over time. These findings should be helpful, according to expectations, while estimating the masses of the planets that are closest to the star. Furthermore, information about the ultraviolet radiation that we anticipate receiving from new surveys study the star's spectrum may provide important information on atmospheric behavior and the characteristics of its planets in orbit. Planets in our solar system, for instance, despite the fact that they have the potential to be habitable, some of them can still be heated. Their air will be warm like a blanket if their atmosphere contains a lot of carbon dioxide, and the entire world will experience high winds. Despite the fact that life won't always be simple if the planet contains a lot of water, some creatures may still be able to exist there. With modern and emerging technologies, we are coming closer to discovering life beyond Earth. Future observatories like the LUVOIR mission and the Habitable Worlds Observatory. Chile's Habitable Worlds Observatory, a ground-based observatory, is assisting us in our search for exoplanets in our galaxy that may be able to support life. The observatory can identify extrasolar planets, potentially use spectroscopic analysis and sophisticated imaging to sustain life. The observatory so far has identified over 20 planets that are in the habitable zone, meaning they might support liquid water, their surface, and might be able to sustain life. The Habitable Worlds Observatory is only one example. There is a chance that the forthcoming LUVOIR mission will discover even more proof of extraterrestrial life. LUVOIR, an unmanned expedition to find and study exoplanets in our solar system, will launch in the 2030s. Galaxy. The mission is outfitted with a number of tools that it is used to find the presence of substances that support life, such as carbon, oxygen, and water. The LUVOIR mission may possibly be able to capture pictures of exoplanets that could assist us in determining whether they have the capacity to sustain life. Please let us know what you think. I appreciate you viewing. We'll talk afterwards. Also, keep in mind to like and subscribe in order to keep up with our most recent and intriguing topics.